Hello, so we are here so that we can extend our learning. I am re-recording this because the audio was really bad and I'm trying really hard to be up close to the mic here. We're going to go ahead and talk about some examples that show up in the maze that we really haven't talked about as a class. So let's go ahead and talk about some of these examples. So a type that we haven't done in class is in this format. So first off, this is a rational function because you have a variable in the top and the bottom. But it just looks differently from what we've been doing lately. But the steps are actually the same. So let me go ahead and show you. Let's go ahead and apply what we've been learning. So step 1, switch f of x to y. Step 2 is to switch the x and y. Step 3 usually involves trying to get rid of that y from the bottom there. And in order to do that, you multiply both sides by the denominator. The y's on the left side right here will cancel. And you have xy is equal to y minus 5. Then you move the y's over to the left side by subtracting y. And from there you have xy minus y is equal to negative 5. After you have that, you're going to go ahead and factor out the y. Remember that there is an imaginary 1 right here in front of that y. So you're going to factor out. Then you're going to divide both sides by x minus 1, and it's solved for. So see, the steps are actually the same, so don't be afraid, even if it looks differently from what we've been doing in class. Oh yes, and of course, step 4 is to rewrite with inverse notation. Alright, so another type of example that we haven't done in class, but of course you have the ability to do, is this type. I am here though just to assist you in that if you see this, don't be afraid, just apply your knowledge. Step 1, switch f of x to y. Step 2, you're going to switch x and y. Step 3, you're going to start to solve for y. So y is right now currently trapped in parentheses to the power of 4. But there's also a 5 out here. You want to get rid of that 5 first before you try to fourth root both sides, because if you fourth root both sides already, you're going to have to fourth root this 5, which is going to kind of cause more problems. So let's first get rid of the 5. Then, once you have that fourth power by itself, now can you fourth root both sides? Now, fourth root looks like this. We fourth root because we want to get rid of the fourth power. Great, so y is almost by itself. You see the y plus 3. Awesome, the opposite of plus 3 is minus 3. The minus 3, please pay attention, is outside of the root. Because you subtracted 3 after fourth rooting, that is not inside of the root. So make sure you write that correctly. And then you got your inverse notation, and you're finished with that one. So this one, oh, I really like this one because we haven't done ones where we have a fractional power. But actually, how to solve it is not so scary, I hope. But we'll see. So step 1, switch f of x to y. Step 2, switch x and y. Step 3, try to solve for y. So first off, we got to think about this one. So I want to get rid of the 4/5 power. Usually we've been doing roots to get rid of powers, but now I'm going to try to push you to think of something else. What if we try to make that 4/5 become 1? Well, I know 4/5, in order to become 1, what if I try to multiply it by 5/4? Because 4 times 5 will give me 20, 5 times 4 will give me 20, so 20/20 gives me 1. If I get 1 as the power, then I get rid of the power, essentially. So basically, that's the technique. Raise both sides to the reciprocal power. Because you notice here, again, 4 times 5 is 20, 5 times 4 is 20. 20/20 will give me 1 as my power right here. And that will get rid of my power. And over here, we're going to have 5/4. But the goal, again, is to get rid of the power right here. Or think of it as the 4's canceling like this and the 5's canceling like that to give you 1. Now, y plus 6 to the first power is just y plus 6. And then y is almost by itself. We just need to subtract by 6. Awesome, so now just rewrite y as f inverse and we are done. I'm hoping that this step isn't that confusing, but if it is, please make sure you check in with the table mate. Because remember, this part I'll be unavailable for until another day. Alright, so the most challenging example that I saw in this maze is one that looks like this. Now I want to say something. When I started to type this out onto my PowerPoint, right, I typed it out and I had no idea how I was going to explain it. No idea even how to solve it. I just know that I'm going to apply the steps that I know to this problem and see if we get somewhere. So let's go ahead and work this out together. Don't be afraid just because it looks scary, but it is okay if you are afraid. But to make you feel better, there's only one problem like this on the maze, and hopefully we master it. So let's go ahead and do this. So step 1, switch f of x to y. Step 2, you're going to switch x and y. Step 3, we're going to start to solve for y. Okay, so the problem I see here is I have my y, it's in the denominator position, which is a problem. And not only that, it's trapped under a square root, so that's an additional problem. So here's how I'm going to go about it. Let's just try our usual routine of multiplying both sides by the denominator so that I can move the y up. I mean, at least if I do that, that gets rid of the root here. And on this side, I'm just going to write the x in front, like so. All right, so cool. The y is now moved upward. It's not in a denominator position no more. But now I have this x right here. It is kind of in the way. And at this point, there's many different ways to go about solving this. But this is what I decided to do. I decided, okay, I know I gotta get rid of the square root. What if I square both sides already? Knowing that the x is still here. That just means I gotta have to square the x too, but you'll see what I mean. So let's first start by squaring both sides. Again, I'm squaring because I'm gonna try to get rid of the root. When I square both sides on this side, I know that the squared has to go to the x and also to the second part, the square root of y plus 2. So it's going to basically kind of distribute. And this is according to exponential laws. When you have a times b to the nth power, it's going to equal a to the n times b to the n. So that's what I'm using here. So in our next step, so this is going to be 64. This is going to be x squared. This is going to become just y plus 2 because the squared gets rid of the square root. This is what that looks like. So again, from here to here, you might have some questions, and I want you guys to discuss it with whoever you're working with. All right, so now I have this, and again, this is in parentheses for a specific reason. The reason is because this x originally was times this whole quantity, the y and the 2. But once I squared that, got rid of the square root, it's still going to be x squared times the whole quantity of the y and the 2. So that's why it's squared. That's why there's parentheses. So what I'm going to do next is I'm going to go ahead and distribute the x squared. And my y is over here. So let's get rid of this because, again, the goal is to solve for y. So we're going to subtract 2x squared. And then we have x squared times y is equal to 64 minus 2x squared. In order to get y by itself, we're going to divide both sides by x squared. So in the maze, they split and simplify. So we gotta split and simplify. And that's going to be your inverse. So yeah, so this one's one of the hardest ones. Yes, it's hard. And it's okay for it to be hard. But I believe in you and I look forward to the work that you have for me on this. Good luck, though.